Hi, this is Edmund, and this is Edmund's presentation for the HeapSort, the Team HeapSort, but just on my own. So, first of all, where we're going to start with is start building the heap with the array. We set our array.length effective to the array.length, which in our case is going to be 5 at the beginning. And then we run the for loop. So we set I is equal to the array.length divided by 2, which is 5 divided by 2, which is 3 or 2, rounding down to the nearest integer. I is less than, I is greater than or equal to 0, and that's how we continue the for loop. And in the process, we keep decrementing I here. Then we start heapifying by passing the array and the value of I, which is 2, which is up here. So here we have to set the parents. So parent is equal to I, which is 5, which is this one here. I is going to be 2. The left child is going to be 2 multiplied by I plus 1, which is 2 times 3, minus 1, which is 5. So left is equal to 5, which refers to this one here. And actually that refers to the array index here, the array value here. We have a tree here that we're going to be used to visualize the heap sort, but everything occurs in the array here. So going back to things, the right child is equal to 2 times by I plus 1. So the right child is 2 equal to I plus 1, which is 3. So that'll be 6. And now once we've done that, we go through the heapify method and we run through these if statements here. And that's where we check the children. So first of all, we check if L is less than the effective length. So is L, which is 5, less than the effective length, which is 5 here. And if the array L, the array index L, which is 6, is greater than the array index I, which is 2. So is 6 greater than 3, which it is. So in this case, the largest index is L, which is 5. We then run the second check here at the bottom. If the right child is less than the array.length. So we have a look, 6 is not less than 5. So we just skip this if method. And then we try this final method here at the bottom. If I is not equal to the largest index. So if I is not equal to the largest index, which it is not, then we perform the swap. And in this case, we take the array that we have and we swap I with the largest index. So in our case, it's swapping the index 2 with the index 5. So if we look at the array, index 2 is 3, and we're going to swap that with index 5, which is 6. So that will be 6, that will be 3. Again, everything happens in the array, but just to make things clear in the tree, we'll show what happens here. We then heapify with the array and the largest index, just to recurse down the tree. So now the largest index is 5 and the array is normal. In this case, because we're passing in the largest index, I is 5, which is here. So now I is 5. The left child is now going to be equal to 2 times I plus 1, which is 6, which is 12, minus 1, which is 11. So that's going to be 11 now. And the right child is going to be 2 multiplied by I plus 1, which is 2 times 6, which is 12. At this point, now we're going to look at these if statements again, right here. And at this point, we're going to see that the left, which in this case is 11, is not less than the effective length, and the right, so this does not occur. The right child, 12, is not less than the effective length, so that's not going to occur. Is I not equal to 5? Now, at this point, I is equal to 5, so we're not going to run this, and we come out of that loop, and we move back to here again. Remember, at that time, I was equal to 2 here. So now, as we go through the loop, we decrement by 1. So now I is equal to 1 now. And we continue to heapify with the array where I is equal to 1. So just to go through things quickly, this is where I is equal to 1 now. Again, run through the code. The left child is 2 times I plus 1, which is 2, minus 1, which is 3. Oh, let me just put that in. Sorry. So the left child is now 3. The right child is 2 multiplied by I, which is 1 plus 1, which is 2. So 2 times 2 is 4. So that's the right child. And you'll notice if we look at the tree, that's what it refers to now. But again, we're thinking of it as the array. We now check the if statements. If L, the left, is less than the array.effective length, which it is, and if the array index at number 3, which is 0, 1, 2, 3, which is 4, is that greater than the index at I here, which is 2? Is that greater? Yes, it is. So now we will say that the largest index is at 3. And you put 5 here again. This is the size of the array. We continue to go through the code and look at the right child this time. Is the right child here 4 less than the effective length, which is 5? Yes, it is. So that passes. Is the array index R array index 4? So 0, 1, 2, 3, 4. That's value 4. Is that 0, 1, 2, 3, 4? No, 5. Sorry. So is the array index 4, which is 5, is that greater than the array index I, which is 1? 0, 1. Is that greater? Yes, it is greater than 2. So now the largest index is now 4. And now we check the final statement to see if the I is not equal to the largest index. When we look here, we see that I is not equal to the largest index. So we perform the swap on index 4 and index I. So I is 1. So we're going to perform the swap with the 2 and the value of 5 here. Just trying to erase that one. Not erasing. Okay, that's gone. Now we know that this is now 5 and this is now 2. Again, everything happens in the array, but we will just show everything in the tree just for the example's sake. Similarly to before, when we completed the swap here, we run, if we look at the code again, let me just get rid of this one, code, okay. Similarly to before, let's tie this up. At this point, it keeps recursing down the tree, but similarly to before, it's not going to be able to recurse anymore. And what happens is at the next point, it's not going to run any of these methods, any of these bits of code, and it'll go back to the for loop again, where I decrements by 1 again to equal 0, which is where we work on here. Again, we're going to run through the code again. So the left child this time is going to be, if we look at the code here, 2 times 0 plus 1, which is 1, minus 1, which is 1. 2 times 1, so that'll be 2. So we're referring to these two. Again, run the code here, so we perform the swap. So again, is the left 1 less than the effective length, which it is index at L, which is at index the value of 5, is that greater than the value at index 0? Is it greater than 1, which it is? So now the largest index is at 1. Look at the right child here now. Is the right child 2 less than the effective length 5, which it is? Yes. Then we check if the index at index 2 of the array, which is 6, is that greater than the value at index I, which is 1? It is. So now the largest index is now 2 instead. Again, we check if I is not equal to the largest index, which it is not, and then we perform the swap. So that now we perform the swap on index 0 and index 2. So now that is 6 and that is 1. Just to prove things again, so index is now I, largest index now is now 2. So we actually, let me just change this one as well. So now that's 6 and that's 1. And now we're going to request down the tree here. So now the largest index is now 2. Go through the code again. Oops. Go through the code again. So now we're going to have a look and see. So now the parent passing the largest index into the array. So I is now the largest index, which is 2, which is at this point here. And now we're going to check if the left child will be 2 multiplied by I, which is 2 plus 1, which is 3. So 6 minus 1, which is 5. And the right child would be the usual again, 2 multiplied by I plus 1, which is 6. And then we check again if the left child is less than the effective length, which it is. That's great. And then we check if the array at index L, which is 5, 1, 2, 0, 1, 2, 3, 4, 5, 3, is that greater than a index I, which is 2, which is, yeah, it is greater than 1. So now the largest index we're going to say is 5, which index is 5. And now we're going to check the right child as well. Is 6 less than the effective array size? It's not, so we're not going to run that bit of code. And now we're going to check is I equal to the largest index where it's not. So we're going to perform the swap. Here we're going to swap the indexes of 2 and 5, which is these two here. That'll be 3 and that'll be 1. And again, we'll swap it here. At this point, again, we run heapify again, but if we run this with the largest index 5, as we did before right at the beginning, we know that's not going to pass any of the values. And at that point, we come to the end of the for loop and we break out of this. And this is where we start to sort things. So now we're going to have a look at things. So I is the effective length now. So I is 5 because that's the expected length. Length effective. As long as I is greater than 0, then we start, we just keep going through and just decrement by I. And this time I'm going to take the array and swap it with the value 0 and integer I, which in our case is 5. This will help us move the max value to the end. So we perform the swap with index 0, which is 6, and index I, which is 1. Index I, which is the 5th one, yep, which is 1. So perform that swap. Oops. So that's 1, that's 6. And we also just show it here as well. That'll be 1, that'll be 6. And now we actually reduce the length effective from, we decremented by 1, so that'll be 4. And then we run heapify again with the array and the index of 0. And at this point, because we have reduced the effective length to 4 now, we don't need to worry about that last array there. So now we are just working with, let me just highlight it, it's fine. But now we are working with a a smaller array now because we're just looking at the effective length, and we're just working with these values here. And again, we just run heapify with index 0, coming back here again and just repeating the whole thing. And I can actually go through that as well quickly as well if needed. So now I is now 0 now. Let me just clear out all these out as well. N is still 5 because that is still the size of the array, but we're focusing on the expected length, which is 4. Again, so we look at things. I is 0, so parent is 0. Left index is 2 multiplied by 0 plus 1, which is 2, minus 1, so the child is 1. The right child is 2 multiplied by 1, which is 2. So we're going to be looking at these 3 here. And then we just go through it quickly again. So if the left child 1 is 1 less than the expected length, which is 4 this time, yes it is, and is the left child greater, the value of the left child is that the value of the index at L, which is 1, which is 5. Let me just clear this out as well. If 5. So array L is value is 5. Is that greater than the array I, which is 0, which is 1? Yes, it is. So now the largest index is 1. We check the right tree here. Is R2 less than the expected array value of 4? It is. So that's fine. We can keep going. Is the value at index R, which is 2, which is 3, is that greater than the value at the largest index, which is 5? That is not greater. So we're going to say, nope, that's not greater. So we're not going to run 2. And then we run the last one, where we check if I is not equal to the index, which it is not. So now we perform the swap. Let's clear this out. So now we perform the swap. So now we swap the array, which is this one here, with I, which is 0, with the largest index, which is 1. So we're swapping the 1 and the value 5. So now that will be 5 and that will be 1. So we swap just those two. And I will pause the video there.